Section 1. A tiny revolution. Introducing nanomaterials. Imagine a world where materials are 1,000 times smaller than a human hair. This is the world of nanomaterials. These materials are so small that they possess unique properties. They behave differently than their larger counterparts. Nanomaterials are like tiny building blocks. We can use them to create stronger, lighter, and more efficient materials. Think of carbon nanotubes, which are incredibly strong and lightweight. These tiny wonders have the potential to revolutionize various industries. From electronics to medicine, nanomaterials are changing the way we live and work. Section 2. Building the future. The magic of 3D printing. Imagine holding a physical object in your hand just minutes after designing it on a computer. This is the incredible power of 3D printing, a technology that has revolutionized the way we think about manufacturing and design. With just a few clicks, your digital creation can become a tangible reality. This is the magic of 3D printing, also known as additive manufacturing. Unlike traditional methods that often involve cutting away material, 3D printing builds objects layer by layer, adding material precisely where it's needed. This technology allows us to create three-dimensional objects layer by layer from a digital design. Each layer is meticulously added following the exact specifications of the digital blueprint, ensuring accuracy and detail. 3D printing is like building a house with bricks, but instead of bricks we use materials like plastics, metals, or even ceramics. These materials are chosen based on the requirements of the final product, whether it needs to be lightweight, durable, or heat-resistant. The printer follows the digital blueprint, adding material layer upon layer until the object is complete. This process allows for incredible precision and the ability to create complex shapes that would be impossible with traditional manufacturing methods. This groundbreaking technology is transforming manufacturing. Industries ranging from aerospace to healthcare are leveraging 3D printing to innovate and improve their products. It's not just about making things faster, it's about making things better. It allows for rapid prototyping, customized designs, and the creation of complex geometries. Engineers can test and refine their ideas quickly, leading to faster development cycles and more innovative solutions. The possibilities are endless with 3D printing, and we are only just beginning to scratch the surface of what this technology can achieve. Section 3. A powerful partnership. Nanomaterials. Meet 3D printing. What happens when we combine the power of nanomaterials with the flexibility of 3D printing? The possibilities are truly endless. Nanomaterials, with their unique properties at the nanoscale, offer remarkable strength, electrical conductivity, and thermal stability. When these materials are integrated into the 3D printing process, we can create objects that are not only lightweight, but also incredibly strong and durable. The answer is a new era of advanced manufacturing. This combination is revolutionizing the way we think about production and design. Imagine a world where complex structures can be printed layer by layer, with each layer precisely engineered at the molecular level. This is no longer science fiction, it is becoming a reality in cutting-edge manufacturing facilities around the globe. This powerful partnership opens up a world of possibilities, allowing us to create objects with unprecedented properties and functionalities. Engineers and designers can now push the boundaries of what is possible, creating intricate designs that were once thought to be impossible. From aerospace components to medical devices, the applications are vast and varied. Imagine 3D printing a prosthetic limb with the strength and lightness of bone. This could drastically improve the quality of life for amputees, providing them with prosthetics that are not only functional but also comfortable and tailored to their specific needs. The potential for customization is immense, allowing for personalized solutions that were previously unattainable, or creating personalized medical implants that release drugs with pinpoint accuracy. This could revolutionize the field of medicine, offering targeted treatments that minimize side effects and improve patient outcomes. The integration of nanomaterials into these implants can enhance their functionality, making them more effective and reliable. This is the potential of combining nanomaterials and 3D printing. The synergy between these two technologies is driving innovation at an unprecedented pace. Researchers and scientists are constantly discovering new ways to harness the unique properties of nanomaterials, pushing the boundaries of what can be achieved with 3D printing. This synergy is driving innovation across various industries, from aerospace to healthcare and beyond. In aerospace, lightweight yet strong components can lead to more efficient and safer aircraft. In healthcare, customized medical devices and implants can improve patient care and outcomes. The possibilities are truly limitless, pushing the boundaries of what's possible. As we continue to explore and develop these technologies, we are only beginning to scratch the surface of their potential. The future of manufacturing, medicine, and countless other fields is being reshaped by the powerful partnership of nanomaterials and 3D printing. The journey has just begun and the possibilities are endless. Section 4: Strong and Mighty Enhanced Properties with Nanomaterials. One of the most significant advantages of using nanomaterials in 3D printing is the ability to enhance the mechanical properties of objects. Nanomaterials like graphene and carbon nanotubes are incredibly strong and lightweight. By incorporating these nanomaterials into 3D printing materials, we can create objects that are significantly stronger and more durable than those made with conventional materials. Imagine a bicycle frame that's both lighter and stronger than ever before. This enhanced strength and durability open up new possibilities for designing lightweight structures, impact-resistant components, and high-performance materials. Section 5: Beyond the Surface. Functional Complexity in 3D Printing. Nanomaterials not only enhance the mechanical properties of 3D printed objects, but also add a new dimension of functionality. We can tailor the electrical, thermal, and optical properties of materials by incorporating specific nanomaterials. Imagine 3D printing a circuit board with embedded sensors or creating a medical implant that releases drugs in a controlled manner. Nanomaterials make these applications possible. This ability to create multifunctional materials and devices is revolutionizing industries like electronics, healthcare, and energy. Section 6: Shaping the Future. Design freedom with nanomaterials. 3D printing already offers tremendous design freedom, but the incorporation of nanomaterials takes it to a whole new level. With nanomaterials, we can create complex geometries and intricate designs that were previously impossible to manufacture. Imagine 3D printing a customized medical implant that perfectly matches a patient's anatomy, or creating lightweight, high-strength components for aerospace applications. Nanomaterials make these complex designs a reality. This design freedom allows for the creation of highly optimized and efficient products tailored to specific needs and applications. Section 7: Challenges on the Horizon, Overcoming Obstacles. While the potential of nanomaterial-based 3D printing is immense, several challenges need to be addressed before it becomes mainstream. One of the main challenges is the high cost of nanomaterials. Another challenge is ensuring the compatibility of nanomaterials with 3D printing processes. Researchers are constantly working on developing new techniques to overcome these challenges. As research and development efforts continue, we can expect to see a reduction in costs and improved compatibility, paving the way for wider adoption of this technology. Section 8: A World of Possibilities Applications Across Industries. The applications of nanomaterial-based 3D printing are vast and span across various industries. In healthcare, we can 3D print personalized implants, scaffolds for tissue engineering, and drug delivery systems. In electronics, this technology enables the creation of flexible electronics, printed sensors, and high-performance electronic devices. The aerospace industry can benefit from lightweight and high-strength components for aircraft and spacecraft. From energy storage to environmental remediation, the potential applications of this transformative technology are virtually limitless. Section 9: A Bright Future. Nanomaterials and 3D Printing, a winning combination. The convergence of nanomaterials and 3D printing is revolutionizing manufacturing and shaping the future of various industries. By combining the unique properties of nanomaterials with the versatility of 3D printing, we are witnessing a transformation in how products are designed, developed, and produced. This synergy is opening up new possibilities that were once thought to be science fiction. This powerful combination enables the creation of objects with unprecedented properties and functionalities. For instance, nanomaterials can enhance the strength, flexibility, and conductivity of 3D printed objects, making them suitable for a wide range of applications, from aerospace components to medical devices. The precision and customization offered by 3D printing allow for the production of complex geometries and tailored solutions that meet specific needs. As research and development efforts continue to overcome existing challenges, we can expect to see even more innovative and groundbreaking applications emerge. Scientists and engineers are constantly exploring new ways to integrate nanomaterials into 3D printing processes, pushing the boundaries of what is possible. This ongoing innovation is paving the way for advancements in fields such as healthcare, energy, and environmental sustainability. From personalized medicine to sustainable energy solutions, the future of nanomaterial-based 3D printing is bright. In the medical field, 3D printed prosthetics and implants made with nanomaterials are providing patients with customized, high-performance solutions. In the realm of renewable energy, nanomaterials are being used to create more efficient solar panels and energy storage devices. These advancements are not only improving the quality of life, but also contributing to a more sustainable and resilient future. This exciting field is full of possibilities, and it's only a matter of time before it becomes an integral part of our lives. As we continue to explore the potential of nanomaterials and 3D printing, we can look forward to a future where these technologies are seamlessly integrated into our daily routines, enhancing our capabilities and improving our world in ways we can only begin to imagine.